Hello everyone and welcome back. In this lesson we're going to talk about arrays, or a simple way to make variables confusing. Okay, so what is an array? An array is a list of any one type of variable. That's actually going to change in the future because we can actually make it of multiple types, but that's something we'll cover in the future, so don't feel like you're just going to be bound to one type. But for now, it's going to be of just one type. So integers, strings, whatever. To define an array, we need to state how long it is, because remember, it's a list. So we need to define how many objects or things or variables or integers are going to be in this list. A name for the array, and of course, the data type. So in the syntax example, int without the capital I, it's just, LibreOffice Impress forces the first character to be uppercase. Couldn't fix that, don't care. It's a lowercase I int. So int left and right square bracket, that's just defining the variable type, that it's going to be an integer array, and the name of the array is A. Now this is something that we've seen before, but we really don't understand it yet. But for now, we're just going to do it, and I'll explain it in a little bit. You would put the word new. New is a keyword in Java. Actually, it should be in C# and C++. I'm not sure about Python or anything like that. But anyways, you put the word new, telling that the computer that you're about to make a new array. You specify that it's int, left and right square brackets, and in between the left and right square brackets, you put a number. That number is how long the array is going to be. That means that in this example, there's going to be 10 integers inside this array. This line of code creates an empty array that can hold 10 integers. The left side is just the definition of the array, or the creation of it really, just like any other variable, and the right side is the initialization of it. Yes, they can be done in two separate lines since they are two separate instructions to the CPU. You can do int left right square brackets A semicolon, and then on the next line do A equals new int 10. Here we see the word new again like we do with the new scanner, just like we did in the past. When we get to classes, that's when we're really going to talk about it. I'll try to kind of give you an introduction to it today, but if it doesn't make sense, don't worry, we're going to cover it more in depth when we get to objects. We'll talk more about that when we get to classes. It has to do with the fact that arrays are reference type variables. They are objects. But we're going to treat them like primitive type variables because they basically behave like primitive type variables anyways. And remember that the difference is that an integer or a primitive type means that you create a section of memory, you allocate or you reserve a section of memory, and you put the number inside it. That's a primitive type. A reference type or an object type variable is when you put a pointer, or in other words, a number that points to another location in memory, and it's that location where the data starts. Doesn't finish there because it's got to take up a lot of space, but that's the point, is that it's too big to fit into one number, so we use a pointer to reference where it is in memory, hence the name reference type variable. All right, the following line hard codes the array. It defines it, initializes it, and not and populates it at the same time. So just like in the last slide, we created a variable called int a, or an array variable called a, but except this time we put curly brackets, and what that tells the computer is that the numbers we're about to use are going to be the actual values inside the array in that list. Right, so the very first number is going to be 40, and the next one's going to be 55, 63, 17. So in my code, if I say, give me the fourth number inside the array, you would get 1, 2, 3, 4, you would get 17. Now that's going to confuse people who know about arrays in a second, but I'm actually going to clarify that, don't worry. This line creates the array shown at the bottom of the slide in memory, right? So here's our array, 40, 55, 63, etc., all the way to 89. The array has 9 values in it. 0 through 8. Remember, here's our 0-based indexing again. The first value is stored in index 0, not 1. This is a very common thing to do. And this is called 0-based indexing. So to explain why this happens, let me see if I can just pull this up. So why do we start at 0? Besides the fact that numbers actually start at 0, there's another reason why we start at 0 in arrays. So the real reason is because let's say that our primitive type variable, right, our integer array starts here. So in code we say int a, oops, how do I undo that? Int left right square bracket a, right? That's right here, right? Eventually we're going to create an array of a few values. 1, 2, 3, 4, 5. 5 values. And this has a number in it that's a reference to this very position right here. The line, this very top part. Not this whole box, but the very top. What the computer's going to do is if you want this variable, this value inside of this index, or in other words, this slot or this point in the array, what we do is, let's say that this is an integer, right? Integers are 32 bits long. So what we do is we say we start at this address, like let's say the address is 1000, and then we're going to add 32 times however many slots we want to go. So if this is 0, we multiply it by 0. If we want this one, we multiply it by 1. And if we want this one, we multiply it by 2. So let's go and multiply it by 2. So it's going to start at memory address 1000 and go forward 64 bits, which is 32, 32, and it stops at this line right here. Then it reads the next 32 bits, and that's how it reads the next value in the array. So in memory, in our computer, remember we talked about random access memory. This is called sequentially accessed memory because we have to start at the 0 and then go forward in sequence from 0, 1, 2, and 3. We just kind of do a little bit of a jump by multiplying it by the index starting at 0, not 1. I know it may be tempting, but do not try to use arrays when starting at 1. So if you want like 10 values, don't make an array of size 11 and then store the first one in index 1 all the way up to 10. Right? Don't do that. It's bad practice. It's a waste of memory. Just use zero-based indexing. It will be incompatible with a lot of other people's code because programmers don't do that. They don't skip the first one just to keep it in line with normal numbering conventions. So in this example, the array is length 9. 0, 1, 2, 3, 4, 5, 6, 7, 8. The first index is 0 and the last index is 8. All right, so let's make an array with 10 cells and use a loop that populates it with 10 random values 1 to 100. Hint, you can get the array length by doing variable.length. So let's create a new project and we'll call it lesson 5 arrays. That's fine. Let's close the other project out. New class. Call it array practice. Open it up. Just like before. I'm going to delete everything. Public static void main string args. And as you can see, we have an array of strings right here, and the variable is called args. We will cover that a little bit later today, but we'll fully cover that when we get to methods, which should be coming up very soon. Okay, so let's make an array with 10 cells, 10 integer cells, right? I think it's 10. Let's make an array with 10 cells and use a loop that populates it with 10 random values for 1 through 100. So let's make an array called int random nums equals new int and 10. Don't forget our semicolon. Now we want to do a loop. You could do a loop that goes from 0 to 10 and just populates it with a random number. We could do that. In fact, let's kind of do that right now. For int I equals 0, I less than 10, because remember, we don't want it to be equal to 10. If we hit 10, something bad is going to happen, and I'm going to force it to error out when that happens. But remember, we want to keep it less than 10. I++, close this, and then do that. All right. Now, I can actually use this variable I to access the individual elements inside the array. So in other words, what I could do is I could do int, oh, I'm sorry, not int, random numbers, random nums at index I equals math.random times 100. Now remember, math.random generates a double from 0.0 to 0.999999999, or 0 to 1 but not including 1. So we need to cast that to an int, right? Sweet. Now this is, remember, we've done this once before, but just to re-explain it, this right here, if I don't have that here, it's going to complain to us. Hover, come on. Incompatible types, possible lossy conversion from double to int, because math.random generates a double. But I can force it to go to an integer, and then now I'm doing integer times an integer, and that gives us a integer. And we can store that in the number right here. So let's kind of follow this through one step at a time. All right, so we have a for loop, and on the first iteration, I equals 0. And I have an array, I'm just going to call it random just for short, of 10 empty values, right? So empty values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, these represent like the little slots, right? The indexes, they're called. Right, so at index 0, it's blank, 1 is blank, 2 is blank, 3 is blank, etc. All the way to 9. All right, so on the first loop, it says go to random nums integer I. But remember that this is the very first iteration of the loop, so I is equal to 0. So we start right here. And it says generate a random number between 0 and 1, not including 1, multiply it by 100, cast the random number to an integer. Actually, I shouldn't do that. I should do this. This is what I want to do. Good. So let me actually explain what I just did, because it's actually really important. If I generate a math.random between 0 and 1, and then I truncate it, or I cast it to an integer, and if I cast it to an integer, which means convert it from a higher to lower variable type. I say higher because, you know, doubles are more precise. So to a less precise number, that's casting it down to an integer. That's casting down. Without the parentheses, it's going to cast that number between 0 and 1 to an integer. However, when you cast it, let's say I generate 0.6753, right? Or yeah, let's say something like that. The way that it casts it is it just takes the decimal and lops off everything across it. So no matter what number I do, it's actually going to always become 0. But if I do math.random, then multiply it by 100, so if I do 0.675, multiply it by 100, right? I can get 67.5, and then cast it to an int, that'll give us 67 instead of 0. So that's why we have to do this first, which is why I put it inside the parentheses. Okay. So far, so good. Not making a lot of mistakes in this video. Okay, so this will be 67. I mean, it could be anything between 0 and 100, honestly. 0 and 99, to be honest. Didn't I say actually in the array? Yeah, I want it to be from 1 to 100. And this right now will generate 0 through 99. So I actually want to add 1. Not n plus 1, just 1. There we go. Now this will get us 1 through 100. So at I equals 0, we do this whole thing, and we store it in the 0th index. Then the loop says do it again. For 1, 2, 3, 4, 5, 6, 7, 8, 9. On 9, it'll still do it, but then I becomes 10, and then remember that the loop increments by 1, so 9 to 10. Is I less than 10? No, it's equal to 10. So it actually skips out and then leaves. So let's do system.out.print line, and then we'll just do random nums at I. We're just gonna store the value and then immediately print it out. I always like to hit enter, by the way. If you ever catch me like going to the next line, it's because when you hit enter, Java will actually check that line and say, is there any syntax errors on there? Are there any problems with it? So I keep hitting enter to make it force it to kind of do the check, which it probably will as soon as you click off of it, but that's why I do this. So let's compile. Class compiled, no syntax errors. Sweet. Right click, main. There you go. There's our numbers. 22, 64, 29, blah, 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 blah. Oh, look at that. The last one was 100. All right, let's clear, close, and then go back. All right, so the hint I gave here was variable.length. So let's try this using a while loop. So let's do while random nums less than random, actually no. Let's do int I equals 0 while I less than random nums dot length I want to do random nums at index I equals math.random times 100. Cast that down to an integer and then add 1, just like I did before, except now I have to do I++ here, and that's perfectly fine. So does this accomplish the same thing as last time? Well, we have no syntax errors. Oh, why is it not running? Oh, because I'm not printing anything. System.out.print line random nums at I. There we go. Array index out of bounds exception. Ah, okay, good. So here's what happened. Let's say that I is equal to 8, because we're going to go through this a couple times. Let's say we skip ahead, right? So I is 0, and then within here it's always going to increment by 1. Let's say that I is equal to 8. Well, length random nums dot length should equal 10. I know what happened. Okay, random nums dot length equals 10. So my mistake was right here. Okay, so on this line, I do store something on index 9, but on the next line, I go to index, I is now 10 at the end of this line. Then on the next line, I try to print out index 10. There is no index 10. It stops at 9. So to fix this, I'm just going to cut this, and I'm going to increment after it instead. I'm going to recompile this. And oh, I should probably clear this and then redo this again, because I know it works. Compile, That error was from the last time we ran. I didn't clear it out. There we go. There's our array of numbers, printed line by line. All right, different ways to define arrays. These first two statements declare an array, but no memory reserved for it yet. So as I said before, I'm going to make this bigger since this is a really small. Okay. So here's one way you can do it. You can define the array, the variable, which is just allocating the memory with no pointer to memory. Right. So you create basically your primitive version of it, but you're not pointing to anywhere in memory. On the next one, you do. Oh, I'm sorry. This is actually pointing out the fact that you can put the square brackets either on the variable type. Go back. You can put it on the variable type at the beginning or after the variable name. These are the exact same thing. But notice that we're not doing any equals, new, anything like that. So in both of these cases, I was right. You are creating the variable in memory, but you're not putting any pointer inside of it. Variable equals new int 10. This line is combined with the previous. This will actually allocate. So this will actually allocate the array elsewhere in memory and generate and reserve 10 units of space. The bottom one, or the next one, double variable like this. This creates an array of 4 values and populates it at the same time. So this kind of does this, but also places the actual values in the array. Notice I just populated an array of type double with integers. This is acceptable because the computer will upcast. When you put it in parentheses and we did the integer, that was downcasting. The computer will automatically upcast because there's no loss of precision. Remember that it's more, when we go from a less precise variable type to a more precise variable type, we don't lose any data. So that's perfectly fine. But going the other way, we have to be explicit. We have to downcast explicitly. All right, downcasting is not acceptable. When downcasting a double to an integer, everything after the decimal will be truncated. So there's a Stack Overflow. What is the difference between upcasting and downcasting with respects to class? Google that phrase and you will find this Stack Overflow entry. So we do my object variable. This will declare an array of objects. Arrays don't have to be primitive variables only. We haven't talked about objects, but anything can be an array as long as it's a variable type. Right? I was gonna say you can't make an array of literals, but you can create an array of integers filled with literals, right? That's what we did right here, actually. These are all literals. So this is an array of objects we'll cover later. Just understand that they don't have to be primitive types for now. In fact, all arrays are technically object types, but we'll talk about objects much later. So if you want to know what the default array values are in Java, go here. So like when we create the values, this variable here, remember how we are defining it in memory? There are some default array values, and Geeks for Geeks has the data on what those default values will be. Usually it's 0. Sometimes it's null. If they're objects, they're null. When you make a primitive type variable, there's usually a default value 0. When you make an array without populating / initializing it like this, the array has a default value of null. Right, so I think what I'm trying to say here is when we do this line of code, but we don't create the array afterwards, we simply declare like the square on the left. So basically, if we do double array, all we're doing is doing this, and then we're just leaving it there. This should be null because there's no pointer. We don't put 0 because 0 is an actual location in memory. Null means no pointer. 0 is a pointer that points at the very, very beginning of memory, which we don't want to do, and which Java isn't going to allow you to do anyways. But once you create an array, this will become some sort of number. It'll point to that location in memory, and the default values inside of here will be 0, usually, especially if they're primitive type variables. Be careful that null is not the same as 0. As I just said, the difference between 0 and null is 0 will point to a location in memory, the very beginning of memory, in fact. Null will not point anywhere. So null has its own value as well. It's the absence of a value, which is a very strange concept to kind of get used to, but that's what it is. The array is initialized and all values default to 0, or 0.0 if it's a double. Great. Hopefully that's not too much for you to handle. It's not too bad, I promise. So let's talk about multi-dimensional arrays. Just like how Excel, Microsoft Excel, any spreadsheet, right, has an X and a Y cell, right? You have row 1, column 1, row 2, column 1, row 3, column 1, and so on and so forth. We can also have arrays that are multi-dimensional as well. Technically, what Java does is it just creates a list inside of a list. So, like for example, it creates an array, a normal one-dimensional array that we've been dealing with right now. But then in the first one, it creates an array inside that array, and then an array inside that array, and it does this infinitely. That's what a multi-dimensional technically is. But we're only going to really go to two-dimensional arrays, really. You can experiment with more, but you can go as high as you want. But when we do it in multi-dimensional arrays, it's good to think about it as if it were a grid. Oops, whatever. I'm not an artist. Don't care. Right? So let's say we wanted to make a tic-tac-toe board, right? Well, this is column 0, column 1, column 2, row 0, row 1, row 2. Syntax for a two-dimensional array looks like this. Every dimension that we want to add, right, because this is dimension 1 going down, and this is another dimension, just like x and y. Every dimension that we want to add, we just add a set of square brackets. And then we say how big it is in the x and how big it is in the y. So this one will create a table with 3 rows and 4 columns. Again, technically, it doesn't actually matter which one's the rows and columns. It knows to put the list inside of the list. I mean, there really isn't any difference. All you're doing is rotating the table 90 degrees. So, graphically, you would do that. But in memory, that doesn't happen. So syntax for a 10-dimensional array would look like this, right? Where the first dimension is going to have 4 values, the second 3, 5, 2, 6, 3, 8, 2, 5, 4, etc. So let's just stick with two-dimensional arrays because it can get real crazy going forward. It may behoove you or benefit you to learn about three-dimensional arrays, since in 3D kind of programming you might use arrays, but that typically actually isn't the case. You'll end up using matrix vectors, but don't worry about that. But it still might be worth it to practice three-dimensional arrays if you think you need it. So let's make a simple calendar. Make an array with 6 rows and 7 columns. Let's start with that. All right, let's make an array with 6 rows and 7 columns, right? Because we want 6 rows because sometimes, let's look at the calendar. What date is it? April 7th, right? So 1, 2, 3, 4, 5, 6. And the reason is because notice that there's half of a week in the first one. And in this month, we particularly don't need to. But what if the month starts on Saturday and has 31 days or 30 days? It'll bleed into the 6th week. That's why we need 6 rows and 7 columns. So let's make a int. I like doing it this way. Calendar equals new int 6, 7, bam. Ask the user what day of the month starts on. So Monday, Tuesday, Wednesday, etc. Then ask the user how many days are in the month. I think for this example, we're going to have 0 be Sunday and 6 be Saturday. So let's make a scanner object. User input, user in equals new scanner, system.in. No, I have to import that. Import java.util.scanner. There. Then ask the user, sorry, system.out.print line. Ask the user what day of the month. What day does the month start on? 0 equals Sunday. Double quote, close that, bam. Okay, so now let's make an integer equals day of, oops, not equals, day of week. And set that equal to 0. Oh, sorry, set that equal to user in dot next int. Right, so let's see. We create our array, and we have to do this line in order to get data from the user. We ask the user what day of the month, what day does the month start on, and then we store that input to the integer day of week. All right, then ask the user how many days are in the month. How many? Whoops. System.out.print line. How many days are in the month? No. Int length of month equals user in dot next int. Awesome. Create a loop that will populate the days in order and then print it out to the terminal. For days that aren't in the month, put a 0. To make printing a bit cleaner, but put a /t, which is a tab character, after each number. So without that, it'll just put the numbers right next to each other, but we want to give some spacing on it so it makes it look a little bit better in the terminal. So we're going to go ahead and do /t after every input. So we're going to need a nested loop. So let's say for int I equals 0, I less than int calendar dot length. Actually, I don't need to do that. Calendar dot length I plus plus. So there's something new here. I did calendar dot length. What calendar dot length is, since it's an array, there's actually 2 lengths, aren't there? There's one in the x and one in the y. How does it know which one it's going to do? If you just do calendar dot length, it'll get the length of the first one, which is 6. If I do calendar square bracket, whoops, this, it'll say skip, what is this? Calendar, I think I need to put an index there, right? Yep. Okay, so it'll say, give me go to the array index 0 on the first dimension and tell me how long it is after that. Now, we just made a 2-dimensional array, which just means that it's a grid. So as far as we care, I could actually put anything in there, and we're going to actually see in just a minute how you can actually change that. But the calendar 0.length tells us, okay, go skip the first dimension, now tell me what the second dimension is. If you had a third dimension, you could put another, do this again, and actually put any number there really, but you can do this again and then get the length in the third dimension. So if you had a 3-dimensional array, each dimension had a different length, this is how you would do that. I brought a drink this time. Okay, so this will go, this is choosing the number of which week we're in, starting at 0 through 6, or 0 through 5. So looking at a calendar, one, 2, 3, 4, 5, 6, perfect. And then we have columns 3, 4, 5, 6, 7. All right, so Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so technically what this loop here is telling us to go row by row, one after another. So it goes here, and then here, and then here, and then here, 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 etc. Now what we want to do is start here and then loop through the days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So that means we need a loop inside of our loop, right? So for int I, or sorry, we can't use I again because I is used in the last one. So we're just going to use j. J equals 0, j less than calendar 0 dot length, j plus plus. Okay, excellent. So now we know that we're going to go day by day by day by day by day. And we're going to store, what we want to do next is take the user's input and store it into this array. Now it's not going to work right away because we are going to have to make an adjustment, but we're going to skip a step here, and we're just going to take the values that the user inputs and store them into day of the week. So day of week, remember camel case, so that O and of needs to be capitalized. I, j, equals user dot next. Oh, I'm sorry. 1. Let's create another variable because I was gonna just go up. Should I do it that way? No, it'll be easier if I just create an integer. Integer day of month. We'll start at 0. Actually, we'll start at 1. So we're going to put day of month inside that array index. And it's going to start at 0, 0, and then we're going to go to 0, 1, 0, 2, all the way to 0, 6. Once we get to 0, 6, note that we've run out of the length here because calendar 0.length is 7, right? So that's the last one. The j is going to increment. This for loop is going to end, but that means that we have to end our first outer loop. The outer loop ends for the first time. So then we go to I, which is number 1. And the first thing that the outer loop does is run the inner loop again. So this is how we go through all the columns repeatedly. And then each time we iterate, we go down a row by doing this nested loop. No. Okay. Day of week ij. Why is this array required but int found? Oops. Okay, now let's just system.out.print equals. We don't want to do print line here. Day, oh, I'm sorry, calendar at ij. So in the first one's gonna be 0, 0, 0, 1, etc. Plus /t, and actually let's do /t like that, and then that's it. Okay, let's run this. It's not going to work. I know it's not going to work, but let's kind of explain what's going on. What day does the month start? Let's say Wednesday. 0, 1, 2, 3. I think that would be 3, right? Is Sunday, Monday, Tuesday, Wednesday. Yeah, 3. What day? So Wednesday. How many days in the month? 31. All right, array index out of bounds. Why? Index 6 out of bounds for length 6. Oh, oops. I forgot to delete that after I explained it. That makes sense. Clear. All right. What day? So 3 is for Wednesday. Well, how many days are in the month? 31. Okay, perfect. So as you can see, all of our numbers are printing out on the exact same line, all on the same line. Come on. And they're all 1. So first of all, I'm going to have to actually increment day of the month, aren't I? But remember, if I do plus plus, it'll increment it afterwards, right? So I also want to go to the next line. What do I do to go to the next line? There's another character besides tab that we can do to go to the next line. Well, there's actually 2 ways we can do this, but I'm going to show you the new way, which is using these escape characters, this backslash. So backslash T is tab, backslash R is return, which brings you to the beginning of the line, but not the next line. Backslash N will bring you down to the next line. But I don't want to do it in the inner loop because then it'll do it after every single print. What I want to do is do it at the end of the week, right? So I want to actually do it down here. And then double quote backslash N. So I've made 2 changes. I now increment the month, or I'm sorry, the day, and then I return to the next line. You know what? It's running, but I forgot to delete the last clear. Let's return and then clear this so it's not as ugly. And then we'll just rerun it. All right, what day? Here, let's put it over here. It starts on Wednesday, which is a 3. 31 days. There you go. 1, 2, 3, 4, 5, 6, 7. Perfect. Perfect. Now we have 2 problems. 1, the day is starting on a Sunday, not a Wednesday. And 2, we're still printing past 31, aren't we? So that's 2 things we need to modify in our loop. So the first thing we need to do is actually do a check on the first index, right? So when I equals 0 only. Yes. So if I equals 0, so we want to make sure we're on the first week. If I equals 0, and we need to make sure that I is not equal to day of week. And I, where's I? I not equals day of week. Actually, let's make sure that it's less than, because what happens if it's Thursday? Thursday is still 0, but it's also not equal to the day of the week. That would also print 0. So it might put 1 on Wednesday, but then the next number will be 0. So let's make sure that it's less than day of week. What we want to do is store the number 0, calendar I, j equals 0. Right? And then otherwise, else, I should put else. Why does it keep throwing a fit? Oh, I'm an idiot. That's not a valid variable name. And then I want to jam this code inside the else statement. Let's see how this does. Three, 31. How many days are in the month? 1, 2, 3, 4, 5, all the way to 35. It didn't go to the 42, and there's only 5 weeks. 1, 2, 3, 4, 5. Let's see what happened. Let's kind of walk through this together. On the first index, 0, 0, which is this first Sunday, I is equal to 0, and I Oh, I'm sorry. We need to do J. J is less than day of week. J is less than day of week. Calendar at ij equals 0. And I'm not printing that first week either. That's why this isn't happening. So I'm only printing it if it's the second weekend on. So I need to do that. So that was two things I had a problem with. All right, now let's try this. It starts on a Wednesday, 31 days. Bam, 0, 0, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. We need to do one more check though. We need to stop once we hit 31 days. And then for the rest of the loop, we just populate 0. All right. So I'm actually going to do, oops, I shouldn't have done that. Nope. Nope. Wrong one. Else if, I think that's else if. J, oh, I know. As long as the day of month is less than or equal to, what was the variable? Length of month. Of month. And then let's kind of bring this back up. All right, now what? Oh, that's right. I actually need to put a space there. I'm so used to not using white space that I forgot that you can actually do the space there. That's what I was missing. Okay. So if we're on the first week and we haven't reached the first day, just populate it with 0. If the day of the month is less than or equal to length of the month, which means like for 1, 2, 3, etc., we need to actually increment the value. So calendar I, so we're gonna actually move this up to this right here. And then else calendar I j equals 0. Now I actually could put this a conditional up here that checks to make sure that it's smaller than the day of the week or greater than the number of days in the month, length of month. But for now, let's just do this. If it's before the first day, we'll put zeros. If it's less than the day of the week, because if this is true, which is always going to be true for these first three, it's never going to hit the else if or the else because it's going to skip it. So I don't have to worry about doing that check over here. But once this starts failing, in other words, we hit the first Wednesday and on, then we start doing the second check, which is day of month less than length of month, which is going to be true all the way up to 31. Or equals to, because we have to do it on the 31st day. We're going to store day of month and then increment 1. Otherwise, if this one will fail and this one will fail, we're going to populate the rest with zeros. Didn't mean to, oh, that's cool. I didn't know I could do that. All right, we're going to populate the rest with zeros, and let's see how this goes. What day does it start on a Wednesday? How many days in the month? 31. Look at that. Sunday, Monday, Tuesday, and then Wednesday, Thursday, Friday, all the way to 31. And then the sixth week is just blank. And that's fine. Let's see that we can test this again to make sure that it is. Let's put, oops, let's just rerun it again. I don't need to put any parameters. It starts on a Saturday, which is a 6. there are 31 days. There you go. We got 2 days into the 6th week and 1 day on the 1st week. There's our simple calendar. All right, ragged arrays. Arrays do not have to be square or rectangular. You can independently define how long each combination of row and column is going to be. This is very rare. Most people will just make a rectangular or square array and just forego the rest of it. If you need a huge, and I mean huge array or a huge number of values, using a ragged array may benefit you, but for the most part, it's not very common. Sorry about that. So here's an example of a ragged array, right? I don't know what these numbers were. Distance, I think they were. New York to New York is 0, but New York to Los Angeles is 2,791. New York to Chicago is 791 miles, and so on. I think that's what that was, right? You don't need a full two-dimensional array. So this is how you would do this. Now, this whole entire thing is the way you make a ragged array, which is why people don't usually do it, because look how much code is in here. So first you make an array of distances, which isn't shown here, but you should know how to make an array of integers. What they do is they go to the first array and make it the length of 5, right? So the first column and make that 5. 1, 2, 3, 4, 5. Now, at distances index 0, create a new array and make that 1. Index 0. Wait. Go to the first column. Oh, no. Sorry, this is the 5th, and then it says go to here and make it a length of 1, which is already it's kind of like just putting one square inside of this. Then it goes to the first array, or the first index, and it says make a new array that's a length 2. Then it goes to the next index, which is down here, 0, 1, 2, and make a new index that's length 3. And it does this so on and so forth. And it's actually populating the values on the next line. So I skipped it over here, but if you look here on the 0, 1, at index 1, 0, right? I think I might be kind of looking at this backwards, but it doesn't matter. At index 1, 0, put 2791, and then just continue populating it. Remember that arrays don't actually mean rows and columns, so this could be like column or row, and then this is the row and this is the column. So row 1, column 0 is 2791. All right, for each loops. I talked about the for each loops but didn't review them. That's because they are only for arrays, or actually other lists too, but for now they're only going to be for arrays. So let's say I say int sum equals 0. I create a for loop, but the difference is all I have to do is put this colon between an integer and array. And by default, the for each loop stores a value of 0 and goes index by index into this array variable and then executes the code underneath it. This loop will go index by index and stores them. So in other more complex lists, for each loops will look at the array beforehand. It does this in the background. I actually don't know how this works in the background, but it goes element by element, regardless of how it is, and then stores or does something with it. It just goes each index. It doesn't matter. You don't have to say how long it is. You don't have to worry about index out of bounds exceptions, which we saw once. You don't have to worry about those kinds of things. This loop will go index by index and calculate the value and then execute the code inside the value, or using the value in the value. That was confusing as hell. I just take the sum and I add this value into it. So at array index 0, we're going to store that value into here, and then take it and then add it to sum. And then we'll, at the end of this loop, the sum will have a value. So this is equivalent to this for loop. I don't. It can't be the end of this. Oh, I guess it is the end of this. Well, I guess that was a bit of a shorter lesson today. I hope that made sense. Let's keep it pretty simple. We're starting to use a lot more of what we know. So today we did an if statement. We did some looping. We made some variables. We did some strings. We took some input. We took an array, and we looped through it to create a very simple calculator. I'm sorry, calendar. Holy cow. The next, I don't actually remember what the next lesson was. Let me check the lesson plan. So let's go to my lesson plan 4, 5. Methods. Ooh, the next one's gonna get fun. So this is the end of like the basic stuff. I know that we can't get very far, but as I said, you got to stick with it. We're getting to the good stuff next. Uh, at this point, it's kind of like if you wanted to learn how to like build a house. Up until this point, all I did was show you what a hammer is and how to use a hammer. Right? A hammer, hammers and nails. Okay, great. But how do you hammer and nails to into wood to make the frame of the house to build the house? That's what the next thing is going to be. It's our first step in laying the foundation to that house, analogously, of course, metaphorically. And we're going to actually start adding functions because that's what a method is. It's functions. So we're going to start using these tools more and more and more as we go on. But I want to thank everybody for making it at least this far because this is the end of like the most basic of basic parts. From here on out, things are going to get a little bit more complex, just a little bit. And then once we get to classes, things are really going to start taking off in lessons after that. So I'm excited to get started on the more fun stuff. So I'll see you guys in the next lesson.